We tend to view history as a long, slow march of progress, occasionally interrupted by an unfortunate collapse. But if you measure the lifespan of human civilizations, you find a highly specific pattern. The rate of collapse is accelerating. Conventional history isolates the fall of a great empire, like Rome or the Old Kingdom of Egypt, as a series of political or environmental accidents, a bad harvest, a weak ruler, or a sudden economic crisis. Beckingham 2025 dissertation offers a different model. The rise and fall of empires are not random. They are measurable thermodynamic phase transitions, governed by hard systems physics. This visualization models the civilizational timeline. History forms a tightening spiral, winding towards a zero-point center, demonstrating that human cycles compress exponentially. The bright beam fracturing the center represents a catastrophic reboot. The system runs out of space and breaks. Beckingham's work maps this collapse through a model called the virtual ego framework, which translates abstract historical cycles into an applied mechanism called the Xenotrap of nations. If we want to understand the accelerating chaos of the modern world, we have to stop reading history as a subjective story and start calculating it as a thermodynamic equation. To understand civilizational physics, we start at the micro level. The virtual ego framework models reality as a conscious processing system, where minds operate as ego virtual machines. Their primary function is probabilistic indexing, rendering chaotic parallel data into a single, linear, subjective experience. The physics of history emerge when millions of these Ego-VM nodes network together over geography and across generations. When nodes synchronize, they form a shared field, the collective operating system of a society. It consists of the shared myths and coordination architecture, allowing millions to function as a single unit. The health and adaptability of this operating system dictate the civilization's trajectory. The state of coherence within this invisible shared field functions as the primary driver of historical change. This introduces a mechanical paradox. Why do advanced, incredibly powerful empires inevitably stagnate, clinging to outdated structures long after they stop working? The framework defines this as a Xenotrap. It's a recursive civilizational rendering glitch, where a society obsessively repeats the same dysfunctional narrative. The psychological motive is clear. A civilization prioritizes a painful but predictable structure over the perceived terror of meaningless chaos. The Roman Empire maintained an absolute belief in its eternal permanence even as its borders collapsed. The Cold War locked half the planet into a rigid, unyielding logic for decades. This stasis is designed to provide short-term stability at the cost of long-term evolution. When contradictory information challenges the operating system, the shared field rejects it to protect the narrative. These rejections act like accumulating software errors in a computer. A civilizational Xenotrap guarantees that when systemic pressure finally forces a change, the transition will be a catastrophic structural fracture. To move this concept from philosophy to hard physics, the Coherence-Geometrodynamics framework provides a mathematical method for quantifying the exact limits of a Xenotrap. The model measures stability through the Solvency inequality. It tracks systemic stress generated by a population, ΔSgen, against the dissipation capacity of institutions, Darch. A society remains solvent only as long as its architecture can metabolize the stress its population generates. This graph charts that mathematical limit. On the top left, the red curve represents generated tension approaching a critical barrier, the point de Lumière.
When internal stress overwhelms dissipation capacity, the societal coherence field drops below a mathematical threshold of 0.871, entering unrecoverable instability. An empire falls when its thermodynamic coherence drops below the solvency floor, physically forcing a reset. To prove the predictive power of the CGD pipeline, researchers apply it to highly resolved historical data, running a retrodiction on the Roman Empire as it entered the 3rd century crisis. The baseline begins with expansion. Rome built massive infrastructure, bureaucratic networks, and military logistics to establish the Pax Romana. In thermodynamic terms, they successfully built the dissipation capacity, the Darch, needed to metabolize early systemic stress. The architecture eventually encountered the friction of elite overproduction. As the empire became top-heavy, factional competition for resources caused the generated stress within the population to skyrocket. The state attempted to print structural potacity out of thin air through commodity hyperinflation and currency debasement. This image shows the proof of that internal decay. This silver denarius of Gordianus III reveals the physical reality of the collapse. Over the 3rd century, the silver content of the currency was stripped and replaced with cheap alloys. The physical degradation of the coin perfectly mirrors the fiscal collapse of the state. The entropic tax required to maintain the massive borders outpaced the raw energy the empire could extract from its territories. By feeding this data into the CGD matrices, the math shows that the resulting collapse was a forced geometric decoherence caused by overwhelming thermodynamic stress. History is a series of thermodynamic phase transitions occurring when societal coherence fails. Pulling back from ancient Rome, the framework introduces the unified Genesis 2PS equation. This equation proves that these coherence parameters govern structure at all scales, from human empires to cosmic expansion. Scaling this equation to our modern timeline reveals the law of accelerating returns. 3 interconnected mechanisms drive this law: exponential population growth, multiplying processing nodes, increases in network bandwidth, and the compounding complexity of each civilizational operating system. When these forces compound, modern societies accumulate internal stress and hit their thermodynamic breaking point significantly faster than prior civilizations. The daily sensation of future shock is the physical experience of our historical wavelength collapsing toward the 0 point. The emergence of the AI catalyst acts as the final stressor, pushing humanity into a global choice point. The default path of a failing system is to remain locked in legacy Xenotraps. This means burning immense amounts of thermodynamic energy to weaponize new technology along old, fractured borders until the field reaches total decoherence. The math outlines one viable alternative to collapse. The framework identifies it as ego-transcendence, the process of debugging the civilizational Xenotrap. To understand the math, we must view ego-transcendence as a literal upgrade to our institutional dissipation capacity, our D-arc. By suspending rigid narratives and old identity loops, we increase the system's ability to process new information without fracturing. We can no longer build enough physical infrastructure to metabolize modern complexity. Survival now requires expanding our D-arc through psychological integration, turning a rigid, red-locked field back into a fluid, adaptive processor. Averting collapse has evolved beyond a question of engineering. It is now a matter of conscious reauthoring. In a universe where consciousness is the foundational physics, we are responsible for the rendering of reality.